Right. So, let me see. Okay, I got them here. Right. Now, the essay. So, the topic. Yeah, so maybe you can just listen for a moment. The topic I want to do should be approved by NCUK today. I don't see any reason why they would say no. For example, last year we did the physics of baseball. This year we can do the physics of rugby. Now you obviously know this game, and you know this game. Do you guys know this game, rugby? You can't picture what happens in it?
I can picture.
Okay, well, so what do you think happens in it?
People's phones break.
Yes, that's true. That's true. But I mean, what do people play with? What's the equipment?
Like helmets and like. You mean like
Good. Yeah, yeah. And what shape is the ball?
What do you call that shape?
Okay, fine. You know it's not round then. Oblong shape. Yeah. Okay, good. All right. So you have the key information. That's what I'm concerned about. So you don't need to be a rugby expert. What you're talking about is the physics in the game, right? And there's many things you can focus on. So for example, you were talking about the bones breaking, right? So what you could talk about is you could find a reference for how much force is required to break a human bone. And then you could look up a famous rugby player, maybe like Irish or something, and you could put in some numbers like they have this mass, you could look that up, they have this acceleration, because you can probably look this information up, like how fast they can run. And you could do a calculation and see how much force is being experienced and if it could break a bone. And you know, you can choose where you want to focus. So maybe some students want to focus more on the ball, that it's a projectile motion, that there's going to be friction. Also, something we haven't talked about in class, which is important, is the spin. So you know when the ball is moving in the air, you can put a spin on it. Now, will the spin affect the motion? It will. Yeah. It could go to the side. Yeah. These are stuff you can read about and put in your essay. You understand? So you really have a wide range of things you can discuss. Yeah?
When you say rugby, is it also kind of the same as American football, or we're just
The only difference really for me is the equipment.
Okay.
In rugby, they actually don't wear helmets
Yeah, or pads.
or pads, whereas in American football they do, which makes it more dangerous
Yeah,
because the players are more reckless.
more inhuman.
Yes, yeah. So I would like you to focus on rugby. They don't. It actually makes it easier because they're not wearing equipment. So you know, when you calculate the force, you don't have to consider what might be absorbed by the equipment or something. You know, it's a direct head-on-head collision. You know. So what we'll do, we'll work on the essay a little bit every week. We won't start with the introduction. We're starting with the main body. And the reason for that is because it's easier to write this way. If you write the main body first, then later you can write the introduction to link up to the main body. Do you know what I mean? So after you write the main body, your introduction can be, well, first I will talk about this, and then I will talk about this. You know, it's much easier to do this way. So we're actually jumping kind of a little bit into the middle and writing the main body part. All right. What I want to give you right now is just a little example, like one small paragraph of what I would like to see as an example. So I'm going to give you this, and you can turn. It's page number. Well, the first page is just what software you need, and I think you have the software already. So you installed an Office program with Column, didn't you?
Yeah.
You can use Dropbox if you want to back up your files. I recommend this. There's another program called OR, but you don't need that for physics. You have Zotero installed, and I use Firefox. It works quite well for me with Zotero. I don't know what you've used.
Windows or Chrome.
Did Chrome work well with Zotero?
Yeah.
No problems? Okay, so the first part is already done. You have the necessary software. So if you just turn to page number 158 of this little booklet. Yeah, what's up with this picture? When I got your email, like, is this Zach? Who is that? I changed my profile picture on my mail to Homer Simpson. So I don't know if you got mail from me recently, like yesterday or something. You'll see.
Oh,
it.
sure, Ling knows who it is.
My picture doesn't show an email.
I'm sure you know who that is. It's Chalon Kwok.
Oh, is it?
Yeah. It was his Steam profile picture.
Oh, okay. Okay.
Right.
So if you look at the, you know the troll face?
Yeah.
Yeah,
You're not going to
it's
say it's based off of him.
No, it is. No, it's not. That is, it's like the equivalent.
Oh, I see what you mean.
Yeah.
Okay, yeah. It's the real life version of it.
Yeah.
Now, no, I think the real life version of Troll is what's your guy's name? The Half-Life 2 fella, Newt, isn't it?
I don't know.
You know, the guy in charge of Valve made Half-Life.
Yeah.
The big fella, what's his name? Newt, is it?
Ah,
Gabriel.
New.
Yeah. He's a troll with his Half-Life 3 never coming out.
Gabriel, yeah.
Yeah. Like, I played Half-Life 2 in school, and I'm still waiting for Half-Life 3. You know,
You know,
it was like
so Gatekeeper
well over a decade ago.
didn't know how to count through.
That's it, exactly. You can only count to 2.
Yeah.
Right, so some guidelines. Are you all on page 158? Yep.
Yeah.
Now, first think about which lessons you can use or what to use in discussing the physics of X. So together, can we brainstorm together? Everybody, tell me what lessons do you think would be useful to link to the physics of rugby?
Chemistry?
Yeah, with the physics lessons.
Kinematics.
Yeah, the physics topics.
Force.
Force,
Impulse.
impulse for sure, yeah.
Newton's laws.
Yeah, Newton's laws, yeah, what else?
Collision.
Collisions for sure, yeah. Two rugby players, each moving at 10 meters per second, collide, you know. What else?
Projectiles.
Projectiles, yeah. Anything else?
Change
Change
of momentum.
of momentum, yeah, that was the conservation of momentum lesson, was it? Or I can't remember what it's called. The rocket science lesson, yeah. What else? Energy,
Mm.
kinetic and potential energy, you know. You could probably work out for a rugby game how much kinetic energy is used up, you know, because you know the player's mass, you could know their average speed. I know they're not always running, so you could kind of estimate how much the time they spend running. You know, you could do things like this. What else? What else? What else? And we have a good few. Is there anything else? Work, yeah. Oh, yes. Now, an excellent example of work would be
The scrum.
the scrum, where they're pushing, so there's a force and there's clearly a distance. So, you could, I'd be very delighted to see anybody who wants to try and work out the work done in the scrum. You know, you could figure out how many players there are. You could figure out what force a player could exert. So, you know, what is it like? How many players are in a scrum usually? 8 on each side, isn't it? So the total force would be 8 times,
It's around 800 to 900
Kilos, yeah.
what is?
The pack weight.
Oh, right, nice. So you have the total mass.
Yeah.
Good, okay. So yeah, I mean, this, you know, the reason I picked this topic for you is to make your life easier. There's so many things you could begin talking about. Okay, so that's a good start. Now, from those lessons, what definitions, ideas, or formulas could you use? So let's take the lesson, the change of momentum. What formula would you use from that lesson?
The change in momentum.
Yeah, the delta P, the impulse.
MV minus MU
MV minus MU
over delta
Not without the T. With the T would give you the force. Yeah. Yeah. Now, and then you need to think, how does this apply to your essay? So where would change of impulse be seen in a rugby game? Yeah, or yeah, which one? Yeah, but I think the biggest change of momentum, right? How heavy is a rugby player? 120 kilograms, maybe more?
Depends on the player.
Forward, yeah.
Yeah. So you're 120 kilograms running forward at say 8 meters per second, and then someone suddenly makes you stop. That's a big change in momentum.
Yeah.
That's a big change in momentum. That will be felt. You know what I'm saying? So yeah, I know the ball has a change in momentum because it comes to rest as well, but the juicy one is if the player comes to rest. Right. Another thing you need to think about is, do you need any tables or diagrams? Now, for rugby, what tables might you have? You could, for example, have a table of players' mass. Maybe you might have a table of players' top speed. You know, things like this. Yeah. Acceleration, yeah, things like this. What diagrams might you have? I would say, Diego, you were talking about having the spin and having the ball turn. I think that would make a good diagram, a force diagram. You could find something on the internet where you could have the picture of the rugby ball, and you could, you could. That would make a good diagram, I would think. And what are the necessary sources? Now, for rugby, there's going to be plenty of websites with player statistics. I don't think you'll have any trouble finding something, you know. So what I want to do next is give you an example of a good paragraph and a bad paragraph on this page. Right? Are you looking at Lynn? So let me, and you can see I have comments down the side. Okay. The formula E equals mc squared can be used to calculate the amount of energy released, normally in the form of heat, when a material loses mass. You've all seen this formula before, haven't you? Yeah. What is interesting to note is the presence of the c, the speed of light, in the formula. This constant, which is about 3 times 10 to the 8 meters per second, does not seem like it has anything to do with the energy released. After all, why should the material care how fast light is travelling when it's losing mass? Also noteworthy is that the c is squared. This means that the output energy produced will be very large. For example, a loss of 1 kilogram of mass will release energy of the order of magnitude 10 to the 17 joules. Obviously, such numbers provide motivation for blah, blah, blah. Then it continues on. So, I want to show you, in this paragraph, there is only one thing I'm talking about, the equation. And yet, I was still able to pull out, a pretty big paragraph, even though the only thing I was talking about was the equation. So, if you take the example of rugby, what might you say? You could say something like, the formula delta P equals mv minus mu can be used to calculate the impulse experienced by a player. What is interesting to note is that if the mass of the player is greater, then the impulse will be greater, because it's an mv. Likewise, if the player is running faster, then also the momentum is greater. Do you see what I'm saying? So even with just one little formula, you can already pull out a couple of sentences to discuss. Now, what is a bad paragraph? The following is bad. In today's modern world of fast changing technology, energy is very important to study, as it has many advantages and disadvantages to people. Some people believe we should use less energy. However, since the coin has two sides, some people believe we should use more energy. In fact, there are those who say mankind has a responsibility to use less energy. Like all things in life, the truth lies in the middle, and I've learned many things studying this. So I'll give you 0 marks for that, okay? Because, why? Why would I give you 0 marks for that?
It's very achieving anything.
Yeah, there's no physics discussed in it. Like, what physics idea did you discuss in it? Is there any physics in that?
Just
No.
mentions energy.
Mention,
Not in any mathematical.
mention the word energy, and you're right, not even in any mathematical way, just in a kind of general concept of energy, day-to-day life. So that's why a paragraph like that will get you no marks, because there's no physics being discussed in it. Yeah? So, don't do this. This is not an English essay. I'll say that again. This is not an English essay. And one more time, so you've heard it 3 times. This is not an English essay. So do not write this one. Goodness sake, I do not want to see sentences like, there are 2 sides to every coin. There are both advantages and disadvantages, and some people believe. Alright? I don't want to see those words. Okay? They'll drive me nuts. These are just words put into EAP essays to make them longer. Okay? They don't add anything to a physics essay. You understand what I'm saying? Yeah. Make sure each sentence adds value. If you can delete the sentence, then you should. If you cannot delete it, then keep it. So if you're reading a sentence and you're thinking, could I delete this sentence? Then that's a bad thing, because it means you have nothing important in it, and maybe you should delete it. Okay? So, to get us warmed up, to get us started, you see on the next page I have a little table here for you. So, this table is just to help you get started on writing some ideas for your main body. Let me show you how you can fill it out. I'll do the first one as an example. So, what have we got? Lesson, concept, application, diagram, and source. 1, 2, 3, 4, 5. Oh. Right, so let me pick an example. I'll pick something like a lesson like projectiles. So I'd write projectiles here. What are the concepts I would like to use from this lesson in the rugby? So I'd like to talk about things like the range. Actually, I think I'll just pick the range. I think I'll pick this as a concept to talk about. And the application. So how can I use this? Well, I think it's pretty obvious. For a rugby player, it's useful to know what the range is, how far you can throw the ball. So the application is for passing. When one player passes to another player. Yeah. I suppose you can only kick, isn't it, for a forward? You can't forward pass, you can only kick it, right? You have to drop it and kick it, yeah. Diagram. So what type of diagram would you have here? I think the type of diagram you would have would be a nice sort of projectile diagram where you would have the rugby ball, you'd have the speed, you could find the speed that they're kicked at, and you could put an angle here. Okay, so what angle would give the most range? You could look this up. I'm not sure what it is for a rugby ball. Maybe it's something like 30 degrees. And then lastly is the source. So what sources would you need? You would need a source for this angle. If you found a website that says the best angle for the most range. Okay. What other source might you need? Well, actually, if you're only talking about that, we'll only need that source. Okay. It's also good to have some calculations. So in the application, you could have some calculation maybe. You could have a calculation of the range. So I'm having a picture in my mind of what I would like to talk about. So my paragraph might be something like, in physics, projectiles provides a way to calculate the player's range. In order to calculate the player's range, one must know the speed at which the ball leaves the player's foot after they kick it. According to so-and-so website, players can kick at 20 meters per second. And then you could say the second factor required to calculate the range is the launch angle. If the players want to have the maximum range, then according to blah blah blah, they would need a launch angle of 30 degrees. By using the kinematic equations, we can calculate the range as, and then you can calculate the range. You know. And then you could finish by saying, we can see that most rugby players can kick to a range of whatever number of meters. You know, I mean, and this is only one topic from one lesson. And then maybe you want to go on to say conservation momentum. You know, so you could say then, you know, like you were saying about the momentum, you could say the ball is caught by a player. You could calculate the speed of the ball hitting the player's hand, and then you could calculate the change in momentum by using the formula. You know, I really think it's not too difficult to start talking about things that you can imagine that happen in the game. Yeah. But today, all I want you to do for today is just to have a rough draft of what things you would like to talk about. Now, what you should also be doing today, which is why you needed your laptop, is looking for sources. Okay? What sources are good and what sources are bad? Have you talked about this in class, in EAP? So what are bad sources?
Sources that are made for general public and not academic.
Yeah. What else? Certain newspapers, yeah. What else now? Maybe things like Diego's Facebook page, you know, things like this. For the physics, what sources should you be using? When you use a formula or a definition, you need to reference where you got the formula or the definition from. The easiest thing to do would be to reference a physics book. I have physics books on Moodle, so you could look in those. It's easy to reference a book because you can get the ISBN number. You know the ISBN number of the book? Each book has an ISBN number. It says it on like the front of the book. Yeah. If you put this ISBN number into Zotero, it automatically makes the reference, which is handy, you know. So you can use books to reference formulas and definitions. You will need to use websites to reference player statistics. Now, if you can find good websites, you know, like if you found a sports website or someone's statistical website, because you know there's some people that would collect the data and put it together in one place. You know, these are good. Okay. What else? I let students use at most one YouTube video as a reference, as long as it's like a good academic video of maybe if you found a good YouTube video of explaining spin, because spin is really three-dimensional, having a video is nice to have an explanation. So you could use one. Maybe sometimes universities put up videos, or like sometimes places like BBC put up educational science videos. You know, you could use one of those. So today's job for today is to have a think about what things you want to talk about. Please pick things you feel like it'll be easy for you to talk about. And most important is start collecting your sources. Today, you want to make sure you have a good collection of sources so you can begin writing. Okay? I don't mind if you share some sources. It's just I don't want a situation where like you have 5 sources and he has 5 sources and 4 of them are the same. Okay? You know, 1 or 2. That's all. Right. Can you get started on that? And I'll come around to see what ideas you have. I can talk to you as well.